So it's my pleasure to introduce Andrea Marcucci from Politecnico di Milano. Please.
Thank you for the introduction. Hi everyone, I am Andrea Marcucci. I am a PhD student from Politecnico di Milano. I'm going to show you a part of my research on artificial neural network, in particular in this case applied to 3D concrete printing. As you may know, 3D concrete printing is acquiring a lot of potential during the last years. It can represent a solution for the technological development that the concrete industry strongly needs to be in line with the more advanced industries. There are a lot of techniques of 3D concrete printing, and the most popular one is the layer-by-layer extrusion. How it works, simply concrete is pumped and extruded through a nozzle, and the movement of the nozzle is guaranteed from a robotic arm that, thanks to which we are able to print very complex shape. There are a lot of pros and cons. For example, one of the pros is the safety. In fact, due to automation, there is a reduced number of workers during the construction process. Another pros can be the costs, because we can optimize the shape of the structural elements, reducing the volume and reducing also the cost as well. And also productivity can be increased due to the automation during the construction process. On the other side, there are some other challenges that we still have to face. For example, how to place reinforcements during the construction, during the printing of concrete. Are the design methods that we have today for designing reinforced concrete elements still reliable for 3D concrete printing? It's a very good question. And durability, because of the interfaces here. For example, here in this picture, you can see that in between layers there are interfaces that can reduce the durability of concrete printed elements. However, there are some requirements from the material side that can allow the printability of concrete mixes. And these requirements are the pumpability. So the material should exhibit a very low yield stress in order to be pumped. Extrudability, in such way the material can be extruded from the nozzle and guaranteeing good quality of the concrete surface of the layers. And buildability, that is tied to the development of strength during the printing in order to allow the deposition of layer one above the others. So there is a lot of interest in 3D concrete printing during the last years, and these are some of the publications over the years, so a very huge increase. Actually, it's not updated, this graph. I made it a few months ago, so maybe in 2023 the publications are even higher than 100. However, what is still missing is a practical use of the literature. Okay, a lot of are the papers, but how can we use the data present in the literature? So the aim of this work is to develop a database starting from the literature. And these are some of the steps I follow in order to collect data. So starting from the database of the paper, to typing some strings to find the papers, to collect them, to accept or reject, and to store the data. So how to accept or reject, I established, it's very popular, a criterion based on frequency, from which, looking at some papers, if those papers are giving information on the very important parameters, I will accept the paper, otherwise I cannot reject it. How to establish if the parameter is important? It is because it's very, very frequent in the literature. So, okay. These are some of the parameters involved in the papers in the literature, and I have to distinguish between mixed design parameters and printing process parameters. So the first are the classical components of concrete, so as binder, water binder ration, the different admixtures. The other parameters are very, very important for the printing because like printing speed, pumping speed, the geometry of the nozzle, and the time of the construction. Why are so important? Because you can be able to print starting from a mixed design, but changing some printing process with the same mixed design, you may not be able to print the same material. So in this work, I will only look at the mixed design parameters. That will be the input parameters for my neural network that I will show you in a while. And as output parameters, I will look at the static yield stress, that along with plastic viscosity, they are the two parameters able to study, for which we are able to study the rheology of fresh concrete according to the Bingham model. This is in fact the Bingham model. This is the shear stress and the shear rate. This is the value at which I'm looking at. That is the static yield stress. So once framed the parameter, it is important to save in the neural network only the most important ones. And this is possible looking at the frequencies for which they are occurring in the database. For example, for the binder materials, here we have the cement, the microsilica, fly ash, granulated bast slag, limestone, and kaolin. And for the input parameters of my neural network, I only look at the first four, since are the most occurrent in the database. The same I did for the additive typologies, so I only took the nanoclay and the superplasticizer. And then for the other input parameters, we have considered the water to binder ratio, the aggregate to binder ratio, and the maximum aggregate diameter, and also the time from the last shearing. That is a very important parameter for the development of the static yield stress, as the output value, the static yield stress, it is increasing with time. And so these are also the distribution of the output value. It is important also to say that looking at the values of the static yield stress, we have to remove a part of the values because they were clearly out of trend. Okay? So in order to make more consistent the neural network. Another filter has been applied because, as we have also seen previously, the measured value change a lot with the testing typology. So, for example, these are the different testing types for which we can measure the static yield stress, and the most frequent one is the rheometer one. So we have only look at the test coming from rheometer. So starting from almost 600 data that are very low, but it is due to the literature. Filtering, we have arrived to only less than 200 values that are then adopted to train the network. And these are a distribution of their values, so the minimum, the maximum, the mode, the standard deviation. So here are some results of the network. In particular, we have used a 2 layers feed-forward network. So the first layer, it consists of the hidden layer that is made of 20 neurons. In particular, this number has been found by trial and errors, okay? Just to optimize the final error of the output. And the second layer is made of the output that is made of just one neuron that is directly linked to the final output value. All the data, as you may know, are divided in training, validation, and test. According to the 70-50-15 rule, so 70% of the data are of training data, 15 and 15% for validation and test. So during the training of the network, what has been done is to that the network calibrate the values of the weights and biases in order to reduce the error. But doing iteration to find those values, then those values are validated with new data coming from the validation. So the risk is to have a very good approximation, very good prediction of the way of the output value according to the training, but yeah, the weights and biases are validated with the new data. Otherwise, the network would not be able to predict new values. And the same is done with the testing data. So the predictability of the network is tested with, again, new data. And this is the overall error that you can see that is very low. So we have also manually tested the network, the neural network, by using 5 different mixes that were completely external to the network. So by inserting the input in this window, we calculated the statistical stress according to the neural network model, and we have seen that the difference between the measured value, so the computed by experiment, and the predicted one, so the error is there are sometimes errors that are very high, so the predicting ability of the network is still low, and this is according to the fact that we have a very reduced number of data for training the network. So 2 ways are possible: or we reduce the number of neurons because low are the data for the huge number of neurons we have in the network. Otherwise, we have to increase the number of data, but it is so far not possible according to the literature that we have. So these are some other possibilities for the use of the database. There are just design charts for which we can plot the values of the statistical stress by varying the aggregate to binder ratio and the Water to binder ratio, or superpasses as a Water binder. The limit is that here we can vary only 2 parameters, and the others are remaining fixed, but the advantage is that it's very, very fast for the design purposes. So going to the conclusions, so although literature is rich of application, the number of data in the database is very limited, especially for ANN applications. The ANN has shown to have a low error, but still far from practical applications because of reduced predicting abilities. The database has to be enhanced adding more data, and it can be done every day. In this case, ANN can be more generic by considering the overall printing process and giving information to the printability of concrete mixes. So thank you for your attention.
Hi, my name is Harold Greb. I'm an owner of a design company for structural engineering. Mm-hmm. And by chance, we designed the Princeton University slab that held the machine that made the injection testing. And I keep wondering, where are we going? What are you going to design? How do you get the reinforcement to work with that injection process? Are you looking for architectural models? Are you looking for, I'm wondering what's the use, the end use?
Sorry, can you repeat? I didn't get the...
Well, in normal concrete, we pour concrete in a form, mm-hmm. and we have reinforcement. How do you build something with the injection system? You're layering concrete. What are you going to make?
I guess the question
yeah.
How do you address the challenge of inserting the reinforcement?
Yes. Yeah, no,
right.
There are, I got it. Thank you for the question, because it's a very difficult question to ask today. You mean how to put reinforcement during printing?
Right, and what is it you're going to be designing with this system? How do you, the usage, I'm looking for the usage.
So far, I think that is, we are still far from the usage on structural purposes of concrete printed elements. And in fact, another fact that we are still far from placing reinforcements. So it's today maybe 3D printing is still not in line maybe with practical applications with load-bearing structures. It's difficult to build with 3D printing structure that has structural purposes. So maybe are mainly devoted to aesthetics. But the other way is maybe to print concrete structures that work in a different way. So maybe following, for example, topology optimized structures that can work mainly in compression, maybe where you don't need to put reinforcements on them, even if in some places, of course, you will need them. But with 3D printing, maybe the co-structure technology is going to change. You cannot print, you cannot build structures that you can do with normal casting and normal Sardan techniques. So the approach should change.
Well,
For reinforced concrete.
Yeah, for sure.
Thin shell elements.
Yeah.
Reinforced concrete, UHPC.
Yeah, of course. Maybe the use of fibers is a possibility to give tensile strength to concrete. Because for reinforcement, it's very difficult. It's something that is not matching to place reinforcement and print concrete. You have to interrupt concrete printing maybe to place a bar and then continue, but it's no longer an automated process. Okay.
I understand. I can see that. For example, we do design for plain concrete, so I do see the application when you say it that way. Thank you.
You're welcome.
I've also, if I can just add, I've also seen cases where, for example, if you're printing a wall, instead of printing from the top, they print from the side. So the rebar mesh is in, and you print layer by layer from the side, and there is a trowel mechanism on the other side to kind of block the concrete and make sure you make a layer. And then you do that, and then you go to the next layer.
Yeah. To add another thing is maybe to do this kind of thing with concrete printing is still not convenient, and it's better to use standard methodologies just to.
One more question.
Thank you. Hi there, my name's Andrew Balte. I'm a local tunnel engineer here in San Francisco. Speaking of applications, I was wondering, we do a lot of shotcrete work where we put the lining of the tunnel up, we put the rebar cage, and then we spray the concrete onto the tunnel. I saw in your presentation you had your variability software. Have you looked into applying that not only to 3D concrete and 3D printed concrete, but also spray concrete?
Yeah, well, actually, before the extrusion, concrete has to have some mechanical performance for which it cannot be sprayed. It's already sticky. If I got exactly the question.
Right.
You mean if the same concrete can be printed both and then sprayed?
Different application methods. Can you use the same model to apply to other types of applications?
Yeah, of course.
That was a very interesting model, thank you.
Of course you can. It's that you will have to change the data and you
Right,
have
right.
to look to other things. But for example, the statical stress, it's something that you can, you are maybe interested as well. So
very interesting to see
the
it
model
applied.
works also for other applications, of course.